What's up guys, this is Youngno. Let's solve this question. In this question, we have a system of equations, two equations, and the system has two distinct real solutions. I think we need to simplify each equation first. Let's distribute -3, then we have -6y plus 54, and on the other side we have this. Let's collect like terms. I'm gonna move that 7y to the left hand side, and we have just y, and on the other side we have -51. Ooh, we already found the value of y. So why don't we plug in this found y value into y in the second equation. Then second equation becomes -51 plus 31. Let's distribute x here. Kx squared minus 27x. This value is -20. So what we have here is just a simple quadratic equation in its standard form. This quadratic equation is supposed to have the same number of solutions as the original system because they are algebraically equivalent. And since the question says the system has two distinct real solutions, this quadratic equation is also supposed to have two distinct real solutions. When it comes to number of solutions of the given quadratic equation, you have to think about discriminant. Let me give you a short explanation about discriminant. Whenever you have a quadratic equation in its standard form, discriminant value, which is notated as capital D, can be defined in this way, b squared minus 4ac. The reason why this discriminant is so important is this D value tells you the number of distinct real solutions of the given quadratic equation. There are three different cases. If this D is positive, that quadratic equation has two distinct real solutions. If D is equal to 0, it has one distinct real solution. If this D is negative, then there's no real solution. Since that equation is supposed to have two distinct real solutions, its D value has to be positive. Let's calculate D value from this equation. B is -27, A is K, and C is 20. This has to be greater than 0 because it has two distinct real solutions. 27 squared, that's 729, and 4 times 20, that's 80. So what we have here is 729 minus 80k greater than 0. 729 greater than 80k. 729 over 80 has to be greater than k. 729 over 80. This value here is 9.1 blah blah blah. Since we're looking for greatest possible integer value of k, it has to be 9. Because 9 is the greatest integer smaller than 9.1 something. So the final answer is 9. We're done. See you on the next question.